Welcome to this new tutorial. Today, we'll create a ERC1155 contract to create NFTs for our mobile game using Remix, Flutter, and QuickNode. The ERC1155 is the token standard that enables the creation of fungible, semi-fungible, or non-fungible tokens within a single smart contract. Unlike traditional token standards such as ERC20 or ERC721, ERC1155 allows for a more flexible and efficient approach to managing different types of assets within a single contract. Today, we will create an ERC1155 Solidity contract for minting any of 5 different NFTs, each with an unlimited supply and a fixed price. This allows us to add revenue to our game by requiring any of these NFTs so that users can play. We will start uploading our NFT images to our QuickNode IPFS service. We go to quicknode.com, log in, and navigate to the IPFS, then Files tab. Here we are going to drop our 5 NFT images that we have created. If we click on any of the files, copy the IPFS URL, and paste it on the browser's navigation bar, we can see our uploaded image. Now we are going to create the JSON files that will contain the metadata for our NFTs. In a folder of your choice, create several .json files, 5 in our case, and name them from 0 onwards. And inside them, we are going to create the following structure: an image parameter. Here we are going to construct the IPFS link for each of our image files uploaded to the QuickNode IPFS service. A name parameter. This should be a unique name for each of your NFTs. A description, which can be the same for all your NFTs, and in attributes, create a list with as many attributes as you like, with parameters, trait type for the name of the attribute, and value for the value you want to give that attribute in each NFT. Now, all of our JSONs will have the same IPFS prefix, only the last ID, the CID, will change. So we copy this information in all of our JSON files, making sure to use unique names in the name parameters and the attributes you want to set up for each NFT. Now it's time to upload our JSON files to the IPFS. These files will represent our NFT off-chain metadata. Now let's write our Solidity contract for our NFTs. We go to remix.ethereum.org and create a new file in the contract folders. We'll start by defining the Solidity version and importing the libraries from OpenZeppelin like you see on screen. We'll also import the ownable and string functionality, as we'll require them soon. Create your contract. We'll call ours Dino NFT and will inherit from ERC1155. Ownable and ERC1155 supply contracts. Now let's declare our constructor, which is a special function that executes only when the contract is deployed. Our constructor will receive an address call initial owner. We'll also declare the ERC1155 constructor with the base URI of our .json files. We are using here a different version of our QuickNode IPFS service base URL, but you can use the same one you used inside your JSON files. Lastly, the ownable constructor will take the initial owner as a parameter. We are required to place this function, update, with the parameters from 2 IDs and values marked as internal, and overriding the ERC1155 supply contracts. Inside it, the parent function is called, with all the respective parameters. This is a requirement to extend the functionality of the parent ERC contracts. Let's define this public price variable with an amount of 0.01 ETH as our NFT price, which will represent 0.01 of the actual currency of the chain token the contract is deployed to, in our case 0.01 BSC for the Binance chain and 0.01 Polygon for the Polygon network. And we'll declare this mapping that will relate addresses to a list of integers where we are going to store the list of IDs minted for each wallet that effectively mints any NFT. This will help us control the minting process a bit better. Now let's create our mint function. This function will receive an ID and amount, both integers of 256 bits. The function is defined as public, to be accessed from anywhere, and payable so that it can receive funds when invoked in a transaction. Our function will call the private mint function that's inherited from the ERC1155 contract with the sender as the address that will receive the NFT, the ID and amount of the NFT, and an empty string as the fourth parameter. Now, to be able to sell our NFTs and profit from the minting process, we will place this require, so that if the transaction comes with enough funds deposited as value, it will proceed. Otherwise, the mint function will stop emitting this not enough funds message. Finally, we'll add the ID of the minted NFT to the list of minted NFTs of our sender wallet, so that we can easily know from the client side what addresses have minted NFTs and all the IDs they have minted. The next important function we'll create is the URI function. With this, we will return the URI of the NFT metadata JSON for the giving ID. This function is marked as public view because it can be accessed from anywhere and will not change the state of the contract. And it's marked as virtual override, the virtual part coming from the parent contract indicating that it can be overridden, and the override part in the child contract to indicate that it is being overridden. Our URI function will return a string with the URI of the NFT for the given ID. To do this, we will declare a string-based seed. Remember, the memory bit indicates that the data will only be stored in memory and not on chain. Now, since we will only have 5 NFTs, we can individually check for the given ID from 0 to 4 and update our base CID variable with the corresponding CID. So we'll get our CIDs for each JSON file from our QuickNode IPFS service and place it in the corresponding condition. After this, we will concatenate the base URI with the corresponding ID using this string function coming from the OpenZappelin-strings.sol utility, and we'll return the full URI. Let's not forget to require that the given ID actually exists within the contract, or stop the function. We'll finish up our contract with a function to return the list of NFT IDs minted by any given account by using our minted NFTs, mapping with the given account as index and returning this list, and a setURI function marked as only owner so that only the owner set in the constructor during deployment can update the base URI of the contract in case we need to update the NFT's metadata URI address. Now let's compile, deploy, and test our contract. Go to the compiler tab and hit compile. Now go to the deploy tab and let's copy the account address connected to Remix and paste it in the deploy tab and hit deployed. So far everything has worked great. Now let's mint an NFT. Open up the newly deployed contract in the deployed contracts tab and open up the mint tab. We'll mint the ID 0 with an amount of 1 and hit transact. We have an error with the message not enough money sent. This is because we are requiring the transaction to be sent with a value of 0.01 ETH to go through. You can use an online page like ETH Converter where you can convert ethers to other units. Let's copy the GWay amount for 0.01 ether and place it at the value field of the transaction with the corresponding GWay parameter. Now we have successfully minted our NFT. Let's use our URI function with the ID 0. We get the string with the JSON URI. We can place it in the browser and see how it is effectively pointing to our corresponding JSON metadata, containing also the corresponding image URI. Let's mint some more NFTs and use our getMintedNFT functions, where we'll place the account we have used in the minting and see how we get the list with the NFT IDs we have minted. We hope you have found this video very useful. In our next tutorial, we will interact with this contract from our Flutter app. Thanks for watching.